Welcome to this tutorial on how to plot a vowel space and analyse it for language learning purposes. This will allow you to compare your own vowels to a native speaker or other reference so that you can target areas to improve your pronunciation abilities. This video is split into several parts. Firstly, we'll briefly cover the idea of a vowel space. This will be a simplified overview of the key concepts required to understand what's going on. We will then move on to a couple of examples demonstrating the practical benefits of using this tool. This will include working out the correct vowel placement for a foreign language and copying the vowel patterns of a specific speaker. Finally, I'll show you how to plot the vowels using Python and Praat. Chapters are provided so that you can skip to the parts of the video that you're interested in. Before we get started though, I do have one warning. There is quite a lot to get your head around the first time you do this. However, it will get much easier and faster once you've done it a few times. Different vowels are formed by changing the position of the tongue in the mouth. If you've ever looked into the International Phonetic Alphabet, you may have come across this type of chart. This specific chart is for Standard Italian, which, unlike English, only has 7 unique vowels. The vowel E is pronounced with the tongue high in the mouth and far forward. By contrast, the Italian U is much further back in the mouth. This is referred to as the backness of the vowel. Now looking at the Italian A sound, you can see that it's much lower in the mouth than the first two. This is referred to as the height of the vowel. When we listen, we detect the backness and height of the vowels and use this to determine which vowel has been spoken. We do this by listening out for specific frequencies in the voice called formant frequencies that are higher than the base pitch of our voice. Backness is closely related to the frequency F2, and height is closely related to the frequency F1. We will use software to detect these frequencies and plot them on a chart. Once plotted, we can compare our results with a native speaker of the language to identify areas for improvement. With a basic understanding of vowel space, we can now have a look at some of the outputs of the tool and how they can be used. This chart is still the 7 basic vowels of Italian, but is now shown in terms of formant frequencies. You can see that the vowels are in very similar positions as before. We can now compare this to my pronunciation of the Italian vowels. We compare the relative shape of the charts rather than the exact frequencies, as the precise frequencies are affected by gender, physical size and age. Looking at this, there are a few observations that we can make. The majority of my vowels are approximately in the correct space, however my U is much further forward. Although this is something unlikely to affect comprehension as it doesn't encroach on other vowels, it's something that I should work on. You can see that my E vowel has an unintentional glide to it. This is something that's actually quite common for English speakers speaking foreign languages, and now that I'm aware of it, this is something that I can focus on reducing. The other thing that we can do is compare with a native speaker. For the sake of example, let's say I'm learning English and want to develop an accent similar to Ben from Refold. I would build a chart of him saying some sentences and one of myself mimicking it. Let's take this sentence as an example.
The conventional wisdom when learning a language is to start speaking as early as often and do it as much as you can.
The chart for Ben is on the left and the chart for myself is on the right. There are a few observations that we can make. Ben has 3 separate A sounds that he uses in the sentence. As and languages are close to sounds that I'm used to, but I don't have the vowel that he uses for can in my accent. Therefore, his can vowel is something that I would need to put specific effort into learning to distinguish from the others and produce. Ben's vowels often glide forward in the mouth. This movement is something that I would need to practice, as this is not a movement that I naturally have for most of my vowels. Finally, my vowels are very centralised compared to Ben's, with do being a prominent example. This is something that I could start to work on with tongue placement and measuring using the tool. One thing to note is that vowels can vary dependent on the consonants that they're surrounded by, so you need to make sure that you're comparing the same words in both cases, not just the vowel. I'll now take you through how to make the plots using Ben's sentence as an example. As prerequisites, you'll need to have both Python and Praat installed. I've left links in the video description to download them. We will now download the scripts from my GitHub page, which is also linked in the description. Click on the green code button and then on download zip. Extract this zip file to anywhere that is convenient to yourself. I'll show you the contents of the folder now. First, we have the data subfolder. This is where we will save the outputs from Praat and the final charts. Buildplots.py does what it says in the tin. We will open this to change some settings later on. Extractformants.praat is a Praat script that was written by ListenLab, whose channel I've also linked in the video description. Let's now open Praat. Close the Praat picture window as we don't need it. You can record directly into Praat by clicking on New, then Record Mono Sound. I'm not going to click it in this example as I want to analyse Ben's sentence that I demoed earlier. To do this, I'll just click on Open, then Read from File. We can then select the recording and hit OK. We now need to tell Praat which sounds we want to analyse. Click on the sound object in the list, then Annotate, then to Text Grid. In the box that appears, type Vowels, and make sure that the second line is blank before hitting OK. Now select both objects in the list, and then View and Edit. Since this is the first time that we've run Praat, we need to change a few default settings. Click on this X to get rid of the IPA symbols. Next, let's turn off the blue pitch line which shows the intonation of the sentence by clicking on Pitch, then make sure that Show Pitch is unchecked. Pitch is very useful when working on your pronunciation, but it isn't relevant for this specific exercise. Finally, let's change the formant detection settings. Click Formant, then make sure that Show Formants is checked. Next, click on Formant again, and then Formant Settings. The first number is adjusted depending on the voice of the speaker. The default is good for female voices, but I'm going to lower this to 4200 Hz since we're dealing with male voices here. Next, we will set the number of formants. For female voices, we can leave this as default, but we're going to drop it to 4 for Ben. For speakers like me, where Praat has issues separating certain formants since they're very close, bumping this back up to 5 can help. The last thing that we're going to change is the window size, and we're going to set this to 0.04 for all types of speakers. That is all of the setup finished, and we can now move on to the analysis. We can see 3 things in the window: the sound wave, a diagram that shows all of the frequencies, including the formants that identify the vowels, and our text grid that we will use to tell Praat what to extract. We can zoom into a specific part of the wave by highlighting it, then clicking Cell at the bottom. If we want to zoom back out, we can click on All. Let us zoom into the first part of Ben's sentence. Let's say I want to analyse the E in conventional and the I in wisdom. First, I'm going to click on the wave and then press Tab to play the sound until I find the E.
The conventional wisdom.
Now I've found it, I can highlight it and play it back a few times to check that I've got just the vowel. You'll see below that there are 4 smooth lines. These are the formant frequencies that occur when speaking vowels. Now that I've got it, I can mark it for Praat to extract by pressing Enter and typing in a name. I will now repeat the same for the I in wisdom. I will highlight and press Tab until I'm satisfied that I've found the vowel. Next, I will press Enter and give it a label to identify it to Praat. When checking it, I noticed that there was more of a glide from the W than I wanted to be included for the analysis. You can actually see this in the second formant. I can drag the boundaries until I'm happy with it. It's definitely worth taking your time at this point. If your end result ends up looking very messy, it's very likely that you didn't manage to isolate the vowel fully. Before we move on, I'd like to highlight that the first and second formant frequencies are nice and smooth with no issues. If they are messy, you may need to change your formant settings. Now we can use the scroll bar at the bottom to repeat the process of identifying all of the words that we're interested in the sentence. Once you've completed everything, click All, and then you should see something like this. Close this window and we will now move on to exporting the data so that it can be plotted. Click on the sound file, Analyse Spectrum, then to Formant Berg. Type in the settings that we discovered suited our speaker's voice. In this case, it's 4200 Hz, 4 formants, and 0.04 seconds of window length. We now need to run a script to export this formant data. Click Open and find the extract requirements.txt file that is in our extracted folder. We just need to change one thing in here. At the top where it says name equals, change the text inside the quotes to the name of your sound file. In my case, I'm just going to type Ben. Hit run, then run. Close the script and you'll see that there's a new object. I'm going to rename it to Ben_formants in order to keep things organised. Click Save, then save as comma-separated values. I will save this into the data subfolder. You may also want to save your text grid so that you can come back to it if you want to make any tweaks. Just click on it, save, then save as text file. We're now done in Praat. Go back to our folder and right-click on build_plots.py. Now, open with, and then Notepad. At the top of this file, we have an explanation of the settings, and then we have the settings themselves. First, we have input files. Since we're only analysing one thing, let's put in the name of our formant file, ben_formants.table, and delete the second line. Next, we need to set the name of the file that we're saving the chart as. I'm just going to call mine ben.png. The final setting that I'm going to change is the title that we've written at the top of the chart. I'm just going to set this to Ben's Vowels. We can now save and close this. In order to run the scripts, we will need a terminal window that is linked to the folder that we extracted. In Windows, the easiest way to get one is to type cmd into the address bar at the top and hit enter. Since this is the first time that we've run this, we will need to install the required Python modules. This command is only needed once, and it's pip install -r requirements.txt. This command is written in the video description so you can just copy and paste it. We can now run the plots. Type python build_plots.py and hit enter. Again, this command is in the video description. So with that, we're now done. Go into the data directory and open the file. If there appears to be any issues, you can adjust your text grid in Praat, export it, and then run the Python script again. You can then repeat this process for any sentences that you want to compare it to. You will find that this process becomes much quicker once you've done it a couple of times. If you skip the example section of this video, it's worthwhile going back to it so that you can see what you can do with the charts that you've generated, including comparison with other speakers. Hope this helps.